Hi, good morning. This is Tutor Malvis. In this video, we are going to be talking about machines. And I need you to be very, very attentive. So basically, what is a machine? A machine is a device that makes work easy. Alright? Machine is any device that make our work easy or that make work to be performed in a convenient way. So let's look at what are the terminologies that we need to consider in machines. Since there's a work to be done, then it means there's a load. Alright. So what does a load means? It means a weight or resistance that the machine helps to overcome. And load in machine is measured in Newton. Then another key terminology is effort. Effort. What is effort? Effort is the force applied to operate the machine. It is also measured in Newton. Alright? Then we have what we call the mechanical advantage. The mechanical advantage of a machine. So it is called MA. The short form is MA. Another name for mechanical advantage is force ratio. Force ratio. Alright. And it is called force ratio because mechanical advantage is the ratio of load to effort. So this is force load and force effort. Load is a force measured in Newton. Effort is a force measured in Newton. So we call mechanical advantage force ratio. And the implication of this is that mechanical advantage has no unit because load over effort is Newton over Newton and they will cancel out. So MA has no unit. Alright. Now, anytime mechanical advantage of a machine is greater than 1, it implies that the machine multiplies force. Machine multiplies force. Because simply, the way a machine makes our work convenient is either by multiplying force or by changing the direction of force or by increasing speed. So if MA is greater than 1, the implication is that machine has multiplied force. Then if mechanical advantage is less than 1, it shows that machine increases speed. Speed is increased. But if mechanical advantage is greater than 1, it shows that machine changes the direction of force. Alright. Then the fourth terminology is velocity ratio. Velocity ratio, or VR for short. What is velocity ratio? This is the ratio of the distance moved by effort. Distance moved by effort all over distance moved by load. So for MA it is load over effort. For VR is distance moved by effort over distance moved by load. Then the fifth one, we have efficiency. We cannot talk about terminologies in machines without talking about efficiency. Efficiency is the measure of how effectively a machine converts input energy into useful output energy. Yes, that's what efficiency is all about. It talks about how a machine converts effectively input energy into output useful energy. Now, one thing you must realize is that efficiency, and the symbol for efficiency is this, eta. Use a symbol. So talking about efficiency, the efficiency of a machine, all right, a real machine is always less than 100. That's very important. So efficiency is less than 100%. For a real world machine, the efficiency is less than 100%. Why? Due to energy loss. But for an ideal machine, the efficiency is always equals to 100% because we assume no energy is lost. So this is technically a real world machine. Efficiency is less than 100, and this is for an ideal machine. Efficiency is assumed to be 100% because we assume that there's no energy loss. Okay, what are the things that causes energy loss in a real world machine? Friction can cause it. Friction causes energy loss. Elastic deformation causes it. Those are the things that makes the efficiency to be less than 100. Air resistance causes it. And we also have sound energy. Sound energy causes it. Okay, so how do we calculate the efficiency of a machine? There are several formulas we can use to calculate the efficiency of a machine. And the first and the most popular is mechanical advantage over velocity ratio multiplied by 100. Another way to calculate efficiency of a machine is work output all over work input times 100. Another way to calculate the efficiency is useful energy all over input energy times 100. So you are going to see that this work output is also the useful energy, while this work input is also the input energy. Then we can also have work done on load all over work done by effort. Work done by effort. Or load times distance moved by load all over effort times distance moved by effort. So these are the 5 ways by which the efficiency of a machine can be calculated. Either mechanical advantage over velocity ratio times 100, work output over work input times 100, useful energy over input energy times 100, work done on load over work done by effort, or load times distance moved by load over effort times distance moved by effort. So this will lead us to talking about types of machine quickly. Types of machine. What are the types of machine we have? Types of machines. All right, types of machines. Basically, we have 2 types of machines. And the first, we have the simple machine. Simple machines. Why do we call them simple machines? They are devices with few or no moving parts. Example of simple machines, we have levers, we have pulleys, All right, we have inclined plane. We have inclined plane. We have wheel and axle. We have screw or screw jack. Then we have wedges. Then number 2, we have complex machines. Complex machines. Complex machines simply are combinations of simple machines. They are combinations of simple machines. So, example, we have cars, cranes, and so on. So, in this video, we are going to be talking about the simple machines, all right? The levers, pulleys, inclined plane, and so on and so forth. So, let's start with levers. Let's start with the levers, all right? A lever is a simple machine consisting of a rigid bar or beam that pivots around a fixed point called fulcrum. Okay, so what are the types of levers that we need to know? We have what we call the first class lever. First class lever, all right? In a first class lever, the fulcrum is between effort and load. An example of first class lever, we have seesaw, and then we have scissors. Then, secondly, we have what we call second class lever. Second class lever. And in a second class lever, the load is in between the fulcrum and effort. So, example of second class lever, we have wheelbarrow. All right, then we have nutcracker. So, it's important you know the examples we have under each class of lever, all right? So, seesaw and scissors are under first class. Wheelbarrow and nutcracker are under second class lever. Then we have third class lever. Third class. Now, in a third class lever, the effort is between the fulcrum and the load. So, what's an example of a third class lever? We have fishing rod. Fishing rod, and we have tweezers. So these are under third class lever. Now, for a lever, the mechanical advantage remains load over effort. The velocity ratio, load over effort. Velocity ratio remains distance moved by effort over distance moved by load, all right? And our efficiency remains what it is, depending on what the question is asking you to do. We have a lot of ways to find efficiency, which we have discussed. So let's talk about pulleys. Pulleys. What do you need to know about pulley system? A pulley is a wheel with a groove along its edge, all right, designed to hold a rope or cable. Now, in a pulley system, it's important to know that velocity ratio is equal to the number of supporting ropes. Number of supporting ropes. So, apart from the conventional formula for velocity ratio, you can use the number of supporting ropes to determine the velocity ratio of a pulley. If there are 3 ropes or 4 ropes supporting the pulley, it means that the pulley has velocity ratio of 4. Then, let's talk about inclined plane. So, let's talk about inclined plane. An inclined plane is a flat surface tilted at an angle to help move heavy objects upward with less effort. And it's important to know that in an inclined plane, velocity ratio is 1 over sine theta. All right? mechanical advantage and whatever remains the same. Then we have wheel and axle. All right. So wheel and axle is simply a circle wheel attached to a central axle. Now in a wheel and axle, what's our velocity ratio? That will be R over R. The radius of the wheel over the radius of the axle. Radius of the wheel over the radius of the axle. Radius of the axle. This is very important. Then we need to know, in a screw or screw jack, what's a screw? A screw is a spiral shaped inclined plane wrapped around a cylinder or cone. So in a screw jack, velocity ratio is 2 pi L all over P, where L is length and P is pitch. So these formulas are very important. You can see that in all of this, what really changed is the velocity ratio. The mechanical advantage remains the same. So in an inclined plane, VR is 1 over sine theta, wheel and axle is R over R, and screw is 2 pi L over P. So with this that we have known, let's see how to use this knowledge to solve different questions on simple machines. So let's begin to attempt these questions one after the other. Question 1 says, which of the following is true about an ideal machine? A. Efficiency is greater than 0. B. Efficiency is greater than 100%. C. Efficiency is 100%. D. Efficiency is less than 100%. Now, the first thing we need to pay attention to in this question is an ideal machine. A lot of students don't pay attention to this kind of detail. So they just rush. In a machine, efficiency is less than 100 and they just pick that. Now, for an ideal machine, don't forget, I said previously that an ideal machine operates without any energy loss. No friction, no waste. All right? And because of that, for an ideal machine, efficiency is always 100%. Now, efficiency is greater than 0. Of course, technically, is greater than 0. But the emphasis of this question is efficiency of an ideal machine is 100%. Efficiency is less than 100%. No. This is only true for a real-world machine. All right? That's theoretically. Then for B, efficiency is greater than 100. This is impossible. So the answer to question 1 is efficiency is 100%. Question 2. A lever is used to overcome a load of 200 Newton by applying an effort of 20 Newton. Find the mechanical advantage of the lever. Okay, be reminded that mechanical advantage equals load all over effort. In this question, our load is 200 Newton and our effort is 20 Newton. 200 divided by 20 will give us 10. And therefore, the answer to this question is option D. Question 3. An inclined plane of angle 30 degree is used as a simple machine. What is its velocity ratio? Don't forget that the velocity ratio of an inclined plane is 1 over sine theta. All right? And sine theta is 1 over 2 or 0.5. Therefore, the velocity ratio is 2. And the answer to this question is option B. Question 4. A pulley system has 3 pulleys, all right, in the fixed block and 2 in the movable block. What is its velocity ratio? Interesting question. Now you must know that in a block and tackle pulley system, the velocity ratio is equal to the number of rope segments that support the load. I said that earlier. So here we have 3 pulleys in the fixed block and 2 in the movable block. So that's a total number of what? 5. We have 3 plus 2. That's a total number of 5 ropes. Therefore, the velocity ratio is 5. Number 5. A block and tackle system made up of 5 pulleys is used to raise a load of 700 Newton with an effort of 200 Newton. What is the efficiency of the system? So first of all, we have load of 700 Newton and we have effort of 200 Newton. So what is the efficiency of this machine? You know that efficiency is mechanical advantage over velocity ratio times 100. Now, what is the mechanical advantage here? Load over effort, that is 700 over 200. 700 over 200 is 3.5. All right. Then what will be our velocity ratio? Don't forget, velocity ratio is the number of supporting ropes. So if we have 5 pulleys here, it's most likely that we have 5 ropes, and therefore velocity ratio is 5 for this question. So we simply say efficiency is mechanical advantage, which is 3.5, over velocity ratio, which is 5. So we have efficiency equals 3.5 over 5 times 100, and that is 70%. So looking at these options, option C is the correct answer. We move to question 6. Question 6 says, a machine whose efficiency is 80% is used to lift a load of 120 Newton, of 1,200 Newton. Okay, so the efficiency of this machine is 80%, and the load is 1,200 Newton. Calculate the effort. Effort is unknown. Put into the machine if it has velocity ratio of 5. So the first thing we would want to do here is find the mechanical advantage of this machine. You know that efficiency equals mechanical advantage over velocity ratio times 100. All right. So our efficiency is what? 80. Or you can say 80, since it's 80%, that's 0.8. So that is 0.8. So let me just write 0.8. Then our mechanical advantage is unknown. And what's our velocity ratio? Our velocity ratio is 5. Now don't forget that mechanical advantage is load over effort. All right. And you already have load to be 1,200 over effort. So if I substitute this for mechanical advantage here, I'm going to have my effort to be equals to load over efficiency times 5. So what is the load? Load is 1,200. So that will be effort equals 1,200 over 0.8 times 5. So the effort here is 300 Newton. So let's go back to that question. Therefore, option C is the correct answer. Question 7. What effort will a machine of efficiency 90%, efficiency is 90%, apply to lift a load? So effort is missing here too. To lift a load of 180 Newton if its effort arm is twice as long as its load arm. Okay, so now you must remember that velocity ratio for this question will be 2. because velocity ratio is effort arm over load arm, or distance moved by effort over distance moved by load. So since the effort arm is twice, so that would be like saying 2 divided by 1. So the velocity ratio for this question is 2. Okay, don't forget that mechanical advantage is efficiency times velocity ratio. All right, so mechanical advantage will be efficiency is 90%, that's 0.9, times velocity ratio, that is 2. All right, 0.9 times 2, that is 1.8. Don't also forget that mechanical advantage is load over effort, and we are interested in getting our effort. So effort will be load over mechanical advantage. So the load given to us is 180, and our MA has been calculated to be 1.8. 180 divided by 1.8 is 100 Newton. So the answer to this question is option D. Question 8. The efficiency of the pulley system shown above is 80%. Find the effort E required to lift the load of 1,200 Newton. Okay, so this is the pulley, this is the diagram, all right? And we said velocity ratio is always equal to the number of supporting ropes. Are we together? This is 1, 2, 3, 4. Or we can just count the number of pulleys, 1, 2, 3, 4. So here, our velocity ratio is equals to 4, all right? Then we have efficiency given to be 80%, and that is 0.8. Then we have load given to be 1,200 Newton. Now, since efficiency is mechanical advantage over velocity ratio times 100, all right, and we have already gotten our efficiency to be 0.8, so we will not have to deal with this 100 any longer. So our mechanical advantage will just be efficiency times velocity ratio. Now, what is our mechanical advantage? It will now be efficiency, which is 0.8 times velocity ratio, that is 4. 0.8 times 4, that is 3.2. Now, why do I need to find mechanical advantage first? Because I know that mechanical advantage is the ratio of load to effort, and effort is what is required of us to find. And I know that once I know the MA, I can know the effort. So effort is MA, mechanical advantage over effort is load over mechanical advantage. Load over mechanical advantage. So what is load? 1,200. Mechanical advantage 3.2. And this will give us 375 Newton. Therefore, option C is the correct answer. Let's move to question 9. A machine raises a load of 800 Newton through a vertical distance of 1.5 meter. So load is 800 Newton and the distance moved by load is 1.5 meter with an effort of 1,500 joule. Okay, so that's effort energy or work input. Effort energy is also known as work input. That is 1,500 joule. Calculate the efficiency, then the mechanical, the mechanical advantage of the machine. If the velocity ratio is 5, VR is 5. Okay, the first thing they ask us to calculate is the efficiency. And you know that efficiency in this case is going to be work output over work input times 100, because we already have our work input to be 1,500. So let's find our work output. Work output will be load times distance moved by load, and that will be 800 multiplied by 1.5. That is 1,200 joule. Therefore, efficiency is 1,200 over 1500 multiplied by 100, and this will give us 80%. So the efficiency of this machine is 80%. So let's find the mechanical advantage. Now you know that efficiency is mechanical advantage over velocity ratio, and you know that mechanical advantage is efficiency times velocity ratio. So mechanical advantage will now be, our efficiency is 80%, that's 0.8. 0.8 times the velocity ratio given to us, which is 5. So the answer to this question is 4. So we have 80% and 4. Therefore, option B is the correct answer. Question 10. Question 10, we have a machine has a velocity ratio of 5. If it requires 400 Newton to overcome a load of 1200 Newton, what is the efficiency of the machine? Interesting perspective. So VR equals 5. If it requires 400 Newton to overcome, that is, effort is 400 Newton and load is 1200 Newton. Then we have to find the efficiency. So the first thing we need to find here is the mechanical advantage. Mechanical advantage is load over effort. That's 1200 over 400. And therefore, mechanical advantage is 3. So don't forget, efficiency is mechanical advantage over velocity ratio times 100. So our mechanical advantage is 3. Velocity ratio given to us is 5 multiplied by 100. Alright? So this will be 60%. Therefore, the efficiency of this machine is 60%. Let's move to question 11. Which of the following statements are true? Okay, let's check the first one. Work done by load is always less than the work done by effort. Of course, that is true. All machines are made of levers, pulleys, screws, and gear wheels. This is not true. This is false. This is only true for simple machines, all right? And in fact, at that, they have omitted inclined plane, wedges, wheel, and axle. All right. Then we have a fishing rod is a machine. So this is true. This is true. This is not true. So we have 1 and 3 to be the correct answer. So all machines are not made of levers, pulleys, screws, and whatever. So we still have inclined plane, we have wedge, we have wheel and axle as part of number 2. So question 12. So the answer to this question is 1 over 3. Question 12 now. A wheel and axle have radii 80 cm and 10 cm respectively. All right. If the efficiency of the machine is 0.85, an applied force of 1200 Newton to the wheel will raise a load of dash. So effort is 1200 Newton. The radius of the wheel is 80. The radius of the axle is 10. And the efficiency is 0.85. Okay. Now, velocity ratio in a wheel and axle is big R over small r. That's the radius of the wheel over radius of the axle. So here I will simply say 80 divided by 10, and that is 8. So mechanical advantage, we are required to find the load, alright, but I need to find my mechanical advantage first. Mechanical advantage is always efficiency times velocity ratio, which is 0.85 multiplied by 8. And this is 6.8. Now that I know my mechanical advantage, I can say load equals mechanical advantage times effort. Why? Because mechanical advantage is over load over effort. So mechanical advantage here is 6 point, we have load equals mechanical advantage times effort. So mechanical advantage is 6.8 times effort given to us is 1,200. If you multiply 6.8 by 1,200, that is 8,160 Newton. And that makes option C the correct answer. Question 13. The following machines apply the lever principle except sugar tongs, wheelbarrow, inclined plane, pliers. Now for the first one, we have sugar tongs. So we have first class lever here, then wheelbarrow, this is second class lever, then inclined plane, this uses plane principle, not lever. Then pliers, plier is first class lever. So the answer to this question is option C. That is the exception that is there. Okay, let's journey to question 14. A block and tackle are used to raise a load of 400 Newton through a vertical distance of 30 meters. What is the efficiency of the system if the work done against friction is 1,800 joule? All right. First of all, you know that your efficiency is going to be work output. For this type of question, work output over work input. Because they have started to talk about, work done against friction, then load times distance moved by load and all of that. So in this question, we have load to be 400 Newton and we have distance moved by load to be 30 meters, right? So what is our work output? Work output is always load times distance moved by load. The same way work input is effort times distance moved by effort. So this is 400 multiplied by 30, and that is 12,000 joule. Now, in this case, what will be our work input? So the work input will now be the useful work, all right, which is work output plus the work done against friction. So that will be 1,200. That will be 12,000 plus 1,800. That's the work done against friction. So that will be 13,800 joule. That's our work input. So the efficiency will be work output all over work input multiplied by 100. And this will give us 86.9%. And that makes option C the correct answer. Question 15. A machine having a velocity ratio of 4, VR is 4, requires a height of 20 kg to overcome a weight of 60 kg. All right? The efficiency of the machine is dash. Interesting. Now, here we are going to interpret kg forces as, let's interpret the kilogram as kg forces, as kilogram forces. So, mechanical advantage will be load over effort. So they said that you want to overcome a weight of 60 kg, so that's your load. So 60 kilogram force over, you need effort of 20 kg, 20 kilogram force. So let's say 60 divided by 20, that will be what? 3. So your mechanical advantage here is 3. Now, velocity ratio given is 4, and they are now asking for the efficiency of the machine. So we have mechanical advantage over velocity ratio times 100. So that is 300 divided by 4, and that is 75%. So option C is the correct answer. Question 16. A machine is used to lift a load of 10 Newton through a height of 5 meters. If the efficiency of the machine is 50%, how much work is done by the effort? So we just did something very similar to this. We have load to be 10 Newton and distance moved by load to be 5 meters. All right. So the first thing you need to find is work output. Work output. Because what is required of us to find is the work input. All right. That's how much work is done by effort. That is work input. So our work output will be load times distance moved by load. That is 10 multiplied by 5, which is 50 joules. All right. Then by that we know that efficiency is what? Work output over work input times 100. And you know that efficiency is 50%. That's 0.5. So what is work input? Work input will now be work output divided by efficiency. So that is 50 joules over efficiency is now 0.5. 50 divided by 0.5 is 100 joules. Therefore, option B is the correct answer. So, question 17. The surfaces of conveyor belts are made rough so as to dash A. Prevent the load from slipping. B. Make them stronger. C. Enable them to carry more load. D. Protect them while carrying loads. So the answer is prevent the load from slipping. Now, because roughening the belt surface increases friction. All right, it increases the friction between the belt and the items it carries. By so doing, there's a firm grip, so they won't be able to slip. Question 18. Which of the following systems is not classified as machines? Okay, a pair of scissors. This is a machine. It's a lever, a compound lever. This is thermocouple. Thermocouple is not a machine. It's a sensor that converts temperature differences into electrical voltage. So this is not a mechanical device. Human forearm. This is a third-class lever. Hydraulic press. This is a machine. It's a fluid power machine. So the answer to this question is thermocouple. And the last question, okay, number 19, not the last yet. A wheel and axle are used to raise a load whose weight is 600 Newton. All right. When an effort of 150 Newton is applied, if the radii of the wheel and axle are 1000 millimeter and 200 millimeter respectively, the efficiency of the machine is dash. Okay, so the first thing you want to do is your load is 600 Newton and your effort is 150 Newton. With this, you can get your mechanical advantage, which is load over effort. So we have 600 divided by 150. 600 divided by 150 will give us 4. So your mechanical advantage is 4. Okay, what of velocity ratio? Velocity ratio will be the radius of the wheel over that of the axle. So that is 1000 divided by 200, and that is 5. So what will be the efficiency? Mechanical advantage over velocity ratio times 100. So that will be 400 divided by 5. And the answer is 80%. And that makes option B the correct answer. So the last question we have for today. A machine whose efficiency is 80% is used to lift a load of 1200. So let's have it. Efficiency 80%, which is 0.8, is used to lift a load of 1200 Newton. Calculate the effort put into the machine if it has velocity ratio of 5. So we have done this kind of question again and again and again. To find effort, we need to find our mechanical advantage. A mechanical advantage is efficiency times velocity ratio. So this is 0.8 multiplied by 5, and that is 4. Now don't forget that mechanical advantage is load over effort. And so your effort is load over mechanical advantage. Load given to us is 1,200 and our mechanical advantage is 4. 1,200 divided by 4 is 300 Newton. Therefore, option C is the correct answer. Please kindly like this video, share it to your friends, and subscribe to this channel. Thank you.